Hello, let's have a conversation about the square root of 2 belonging in the set of, let's say, the real numbers just without the rational numbers, which of course is the irrational number. And that would be more or less the same as saying that the square root of 2 is not in the set of rational numbers. So how are we gonna go about this? Let's go use proof of contradiction. Oh, I have to move my, there you go. Contradiction. And what is that? Well, let's say someone claims or is of the conviction that the Earth is flat. And let's say that you are of the conviction that it is indeed spherical or round. Well, they're both round, but this is pizza, coiny round, and this is football round. So what you do is that you tell your friend, well, let's go look for the edge, shall we? So you just keep walking in some direction, and you can tell your friend, when we reach the edge, you're welcome to give me a little push. Well, that was dark, but let's go look for the edge. And let's say you actually do that, and you keep walking, and lo and behold, you end up where you started. Thereby you fail to find said edge, and thereby proving that the Earth is indeed spherical. That's proof by contradiction. So we're gonna start out by saying that the square root of 2 is indeed flat or a rational number, which is sometimes the same. Okay, so let's look at rational numbers. They are made, let's try that again, made out of they can be written as a fraction for which that a comma b is in the set of integers, and b has to be different from 0 because we are dividing by b. So that's our assumption or claim. So we would say that the square root of 2 can be written as this fraction here, a over b. And the thing to be said about this fraction, that it has to be, the two integers have to be co-prime, meaning that the greatest common divisor is equal to 0. So that's, the whole proof is contingent of this fact here. So we can square both sides here. So we have 2 equals to a over b squared, and which of course is the same as a squared over b squared, and we can multiply by b squared. So we have 2b, or no, I won't, 2b squared equal to a squared. And the thing about b squared is going to end up being some number. And when you multiply some numbers, so over here we have 2 times a constant, that's some number. That's the definition of an even number. So whatever this is, multiplied by 2, that's even. So thereby we can see that a squared is even. And if something squared, this thing squared, is even, then this something is even. Thereby we can see that, well, we can say that 2 times a constant is equal to a squared, and then got the whole thing with when you squared and you're even, then you are even. A is an even number. There you go. And okay, therefore we can say that A can be written as such. A equals to 2 times some constant. So let's put this expression of A in here. No, in here. So we can say that, continue the proof here, that 2b squared is equal to, this was A, squared. And let's distribute this exponent here. So that would be 4c squared. And we can divide both sides by 2, having b squared equals to 2c squared. And again, like we saw over here, we got c squared is going to be some number, and 2 times some number is the definition of an even number. Therefore, b squared is even. And if b squared is even, whatever gets squared is also even. So thereby we have, well, b can be written as 2 times some constant, and you know, b is an even number. And this whole thing about this fraction here being coprime, greatest common divisor equal to 1, does not hold if we have an even number over an even number. Thereby we have a contradiction. We failed to prove that square root of 2 was a part of the rational numbers. And that leaves us with the square root of 2 being irrational number. Thank you.